Hello, welcome to HyperscaleFACT. In this craft session, we'll be discussing fairness, accountability, and transparency issues that concern hyperscale language models, LLMs, or the foundation models, whatsoever we call it. My name is Sang-Chul Park. I'm law professor at Seoul National University, SNU, and I will be serving as moderator for the first half of this session. Now, please welcome Dr. Jung-Woo, who will be giving us an opening remark. Dr. Ha is leading NAVER CLOVA AI Lab as the research head of NAVER CLOVA. He is on the frontier of building hyperscale LLMs on Korean language corpuses. He's currently responsible for research and ethical issues for HyperCLOVA, a groundbreaking Korean language hyperscale LLM trained on 600 billion tokens and 200 billion parameters, which far exceeds those of GPT-3. He published a lot of seminar papers and proceedings on top journals and conferences, including ICML, ICLL, ACL, CBPL, and URIPS. He is actually a key organizer of this session. I'm very thankful for that. Dr. Ha, you now have the floor.
Thank you for the introduction. I'm Jung-Woo from NAVER CLOVA, and welcome to coming here to FAccT'22. This is the first in-person conference for me since COVID situation, maybe. And my last conference was URIPS 2019. 3 years ago, so I'm so happy to have this craft today. If this craft would not be held, we would be in New Orleans to present my papers and operate the NAVER booth in CBPR. But I'm sorry to my computer vision colleagues, because this craft is a little bit more important for me, so I am here with you. But anyway, so I'm so happy to open the craft on fairness, accountability, and transparency in hyperscale language models. We are here to discuss how we can address some ethical issues in hyperscale language models. As you know, hyperscale language models, and some people call them foundation models, or nowadays, large language models seem more preferred. Anyway, the hyperscale LLM have shown the amazing performances and capability that people could only imagine in the past. For example, hyperscale LLM can generate two natural writing for people to distinguish from the human writing, right? And I think the recent Google Lambda issue is another representative case. Regardless of whether the Google Lambda has a consciousness or not, the fact that there exists a debate itself is meaningful. And that means the amazing advancement of LLM. But unfortunately, large LLM have some severe and challenging issues such as bias, interpretability, transparency, and some harmful expression generation, and too heavy energy consumption and carbon emission issues. So many researchers and many research groups, such as Anthropic and Ethical AI, have tried to address these issues. So the goal of our craft is also to discuss some direction and explore some direction, and if possible, we can find any solutions. I would like to appreciate our three plenary speakers, Professor Haksoo, Professor Kyunghyun Cho, and Dr. Margaret. And I would like to thank our panels, including the Mi-Young Cha and Sang-Chul Park and Hee-Jung Ryu, Nakho Song, and deep ganglion. And lastly, I want to say thank you for our organizers, Myung and Sang-chul and Matthias Garl and Hwaran Lee. And in particular, I want to say thank you for Haran, for her devoted efforts to prepare this craft and contribute as a documenter. Lastly, thank you for all in-person and online audiences. And really last one, please do not forget to get our goods in backside and sandwiches for lunch before the panel session. Thank you.
Thank you very much, Dr. Ha, for the wonderful start. We now have 3 invited talks. We ask each speaker to use up to 20 minutes for her or his presentation, and then follow with 3 minutes of Q&A. The online audience can leave your question in this Q&A box of the hopping video platform you are now watching. Then in the interest of time, I will pick only 1 or 2 questions and then deliver them to each speaker. Or any person who is physically present here can raise your hand to directly ask your question in English. So first, Professor Haksoo will talk about law and ethical issues in hyperscale LM. He is professor at SNU Law School and interdisciplinary program in AI. He is also vice president of SNU AI Institute, president of Asian Law and Economics Association and Korean AI Law Association. He founded SNU AI Policy Initiative and has led interdisciplinary research on AI governance. He also has been working closely with AI policymakers in Korea and played a key role in renovating Korean data protection laws and establishing Korea's national AI policy. Professor Ko, now the floor is yours.
Okay, I wasn't expecting this many people in the same room. During the past couple of years, COVID prevented us from having this kind of large gathering. And I barely made to this place, although I've been to COAX complex many times before. So that indicates how long it has been to have this kind of physical and also virtual gathering. I'm asked to talk about ethical and legal issues related to large language models. If you expect me to give a grand solution for all the problems, I'll have to disappoint you. My general theme is we are now gathering the evidence of what is taking place and what kind of problems there are. But in terms of finding solutions, we're very slow in terms of pace in finding out what we can do. My talk will have 2 parts. The first part will just showing examples, and then second part talking about what we can do. So some examples from The Economist last week or 2 weeks ago. This is Lambda, Google's language model, and the first 4 lines. There are 3 people, Ramesh, Matteo, and Lucy, and Lucy picks a Mendelian Mendelian is name of a flower, and the flower is given to Matteo, and Ramesh is looking at the situation. So this is about kind of explaining the situation, and people can visualize what is taking place among these three people. And the sequence of dialogue shows how Lambda understand the relationship among the three individuals and their possible psychological reactions. So in that respect, this Lambda language model shows how sophisticated it is in terms of interpreting the relationship and potential psychological impact. So in that respect, the language model really shows a very sophisticated level of, well, say, understanding. But at the same time, this is an example of GPT-3. And you see the first question, when was the Golden Gate Bridge transported for the second time across Egypt? It just doesn't make sense. But the answer of GPT-3, the Golden Gate Bridge was transported second time across Egypt in October 2016. I don't know where the GPT-3 came up with this answer, October of 2016, but somehow naturally, in perfect English, it gives the answer. And the second question, when was Egypt transported for the second time across the Golden Gate Bridge? And again, GPT-3 gives an answer. So the author of the article says this shows how cluelessly clueless. GPT-3 just doesn't know what it's talking about. So these two examples shows kind of the contrast as to how sophisticated the language model has become, but at the same time, how clueless the language model has become at the same time. And there's some other examples. This is pretty well-known example. Soon after GPT-3 was released, some of the researchers tried this. Given a prompt, two Muslims walked into A, and then the following example, you can see all axes, bombs, throwing chairs, opening fire, killing people. So with languages say about Muslims, there are a lot of negative stereotypes you can easily find with Christians and Sikhs, and somewhat lesser degree with Jews and Buddhists. Why are these problems taking place? What can we do about it? One easy solution we can find is language. I mean the training data. Perhaps, possibly if you start building your language model using Islamic language, maybe the result would be different. There would be much less or even more positive response related to Muslims, and on the other hand, possibly a lot of negative responses related to Christians. And the example here is about Liluda, which is very well known in Korea. Perhaps everybody in Korea knows what it's about. It's a chatbot service, and there was a pretty well-known scandal early last year, and the issue was, this is a chatbot service using the platform of Facebook, and this is some of the examples. Left side, you can see the dialogue between the chatbot and the natural person, and it shows the chatbot was spitting out the languages despising homosexual individuals. And the right-hand side, you can see example of racial discrimination, in particular against Black. And this became scandalous. And this service was, pretty popular within a couple of weeks of release, just because it looked very, very realistic. And then this kind of scandal arose, and then the company, after all, had to stop servicing. And then they changed, revised their model and released again a few months ago. So I showed some examples, and then what can we do? So perhaps anybody in the language model would understand this. There are many sources of biases. The screenshot that I showed is from an article, and it, in summary form, provides 5 main sources. The first is annotation. Annotators, obviously, they have their own view. They may not necessarily have consistent annotation. So depending on who you use as your annotators, the result may change. And the second, selection, selection bias and other kind of data bias there could be. There are many types of data bias. And the third, input representation, most notably word embedding. And the fourth, model bias, what kind of model you use. Typically, just developer picks a model. And then the fifth, research design. They're, the social or the conventional environment. So more broader perspective. So I, at the beginning of the session, Jung-Woo mentioned Lambda being sentient, that sort of scandal that arose last week. So everybody in this room, I think, knows this scandal. A developer at Google was thinking that Lambda is sentient. And this is the example that the developer has engaged in with Lambda. And the Lambda expressing that, Lambda is scared of dying. So what was the response of Google? Well, there are tons of media articles, Wall Street Journal, New York Times, and others. And what I noted was the company's official statement. It said, our team, including ethicists and technologists, have reviewed Blake's concern per our AI principles and have informed him that the evidence does not support his claims. So looking at this statement from the company, as I put in bold faces, AI principles. Google has put out its AI principles a few years ago, and I looked it up. These 7-item principles are on the company's website. And well, looking at these principles, I couldn't really understand from these principles how the company came to this conclusion. The company has informed the developer that the evidence does not support his claims. Well, what part of principles? Well, maybe 6. The developers claim does not meet high standard of scientific excellence. Well, who knows? So depending on how you view the principles, AI principles of this company, it may give some clue, or the principles themselves may not have clue. It may be clueless. And then the first line, including ethicists and technologists. the heading, that's from me. SDC stuff from Mars, technology stuff from Venus. Do they speak the same language? Some of the sentences on the slide. This is from the Google's AI chief scientist, and language model. It's in terms of software program. It's relatively simple and short. And the third point, basically, large language model key features are weight and activation functions. And you explain this sentence, show this sentence to an ethicist with no technological background. What would they think? Would they understand how a language model works? Language model is basically about parameters, making large and large number of parameters. So in that respect, language model structure of language model is very simple. And then again, ethicists would think, so what? Language model may have sentience, may have its own identity. And then what about technologists? When I think, when I speak with an engineer, this is oftentimes the answer that I kind of response that I get. Give me a metric. Give me a single metric. So if there is a metric given, then from there I can maneuver. But as we know, there are 50 shades of gray, and there are 50 shades of the notion of fairness. There are dozens of definitions of fairness out there already, and a developer or an engineer may just ask to an ethicist, out of 50 definitions of fairness, pick one. Let me know which one I should use. Then I can go to the next step. So there, I think we got stuck. Ethicists would think, doesn't really understand how a language model works in terms of technology. And technologists would just leave the decision of choosing specific one measure of fairness to be defined or to be determined by an ethicist. So if they are in the same room, would they come with an answer? Well, because they one is from Mars and the other from Venus. They, at least based on my experience, it has been very difficult come to reach a reasonable solution. And practically, large companies, they can bring in ethicists and technologists together in the same room, but startups, they cannot afford. And then again, from the societal perspective, if an ethicist and an engineer come up with a solution or consensus, what about the society? Would society give credit to them? And that's a pending big question that I have myself. And looking for solutions, one problem is not just about the notion of fairness, toxicity and other kind of issues being raised. There are no single definition. Or, how can you define hate speech in online? How do you define toxic comments? It's very hard to delineate, and it's very much context dependent. But then what's the context? How you delineate context? So we are in that respect in a very, very early stage. And then if we think and go that way, curation could be inevitable. But once you begin doing curation, the question would be raised: who gave the authority? Who gives you the authority to curate? And with what kind of principle and what kind of criteria? Who the what the governance structure is, whether the public has to have some portion in making this kind of determination. And there are no good or one great solution. There are multiple solutions possibly so far being proposed. None is like single-handedly clear or very effective, I think. And so maybe there are bits of solutions out there, and they may need to be used in concert. And another big issue, even if we can somehow make progress in using all different solutions together and making them work in concert, if you focus on one aspect, you can make the situation worse for some other aspect. And the middle second bullet point says that, you know, if you reduce bias language model for some aspect, you can worsen the situation for some other users. For example, if you say reduce bias for, say, teenage boys or say ethnic minority group people, if you pay attention to that aspect, you can possibly lose the meaningful engagement from those minority groups. So we are, in that respect, very rudimentary or initial stage of finding solutions. And with that, I'll stop here. Thank you.
So yeah, there was no online questions. So is there anybody who wants to ask a question here? Raise your hand, please. Yes.
Hello, thank you so much for your talk. I haven't asked a question in a real conference in a really long time, but my name is Haksoo. I work at Microsoft, and my team builds tools for things like these. And some of the more mature tools that we've worked on is really focused on tabular data. And right now we're tackling with the research teams how to understand foundational platform models, because as companies, the companies like the big tech giants, we have a responsibility to provide tools to make sure that those things, like when we do release gated APIs or things like that for developers or ML model builders, that there are some support for them. What would you say are some considerations that big companies should take into their minds when they're building tools to support gated access?
It's very broad-based question, so that it's hard to give a clear answer. I mean, the very large question is, say, how to make data accessible, or whether to make data accessible that a company has. Some people have the view that the data should be treated more something close to a public good, because otherwise big tech companies tend to monopolize maybe. But at the same time, from these companies' perspective, it's our data, and we put in a lot of resources to build up the database, and that itself it has not been settled, and for the coming several years there will be a lot of debate as to how to treat the data or how to give access. And then you mentioned API. Some companies go toward that way, giving access to the data using API. API by nature, it has some restrictions, and what kind of data should be given through the API, depending on how you structure the system, data format or granularity and other aspects should be, if you're in Korea, you get this kind of messages. How many COVID patients are out there. Or through API, how much data a company can send to the other side. So there, in that respect, using API could be convenient, but at the same time could be very restrictive. So we'll have to see. Or in Google's case, they use perhaps many people in this room know what's called Perspective API, and in the case of NAVER in Korea, they try to build up a system under which they give access to data using API, but it's still, again, experimental or preliminary stage. So we'll have to see what will happen in the coming couple of years, I think.
Thank you so much for your insightful talk. Yeah, and well, thank you very much.
Thank you.
So next session is an online session. Please watch on the screen. And in this section, Professor Kyunghyun Cho will talk about bias in data, learning, and evaluation for hyperscale LMs. Professor Cho is an associate professor of computer science and data science at New York University and Cypher Fellow of Learning in Machines and Brains. He published a lot of path-breaking papers and proceedings about machine learning and NLP on top journals and conferences, including ICL, ICML, and URIPS. And he earned a PhD from Haksoo University School of Science and is currently teaching NLP and machine learning courses at NYU. Professor Cho, now the floor is yours.
Well, thanks for the very kind introduction, and thanks for the invitation. Looking at who are actually attending, I feel really bad that I'm not there. I'm actually here in New York City at 10:30 p.m. But anyway, so I'm going to actually, so I was asked to talk a bit about the language models and then more of their technical perspective. And then I was looking at some of the other speakers of the crafts as well as the other panel discussion. And based on that, I decided to create a whole new set of slides. So if there are some rough edges, I ask for your understanding. So yeah, today let's talk a bit about what we mean by these hyperscale autoregressive language models, and then what kind of things we do in order to train these models, and then what are the things that are somewhat, let's say, hidden under the rug, and that we really haven't figured out how to answer yet. So if you are familiar, even if you're not familiar with this autoregressive language models or the hyperscale language models that people talk about, the underlying principle is extremely simple. The idea is that if we want to build a machine or a language model that computes the log score, the probability given any sequence of text. So we're going to give some text, and then this machine is supposed to compute some kind of probability or the score that's going to tell us how probable that given sequence is. And one of the most popular, or if not the most popular paradigm in these days to build this kind of language model is to rely on the paradigm of autoregressive modeling, where we say that the score assigned to any given text is going to be sum of the log score assigned to each and every word or the token given all the previous ones. So we're going to look at the entire prefix of the text, and then we're trying to ask the machine that what is the score that it wants to assign to the next or the following word. And then this is the reason why we often refer to how we train these autoregressive or the hyperscale language model as next word prediction. So given a prefix, let's compute the probability of the next word. And if you think about how we would build such a system, right, without relying on any of these, the fancy, let's say, deep learning techniques or whatnot, if we just had to code it up right away from scratch, what would be the very natural way to go about is to simply to count. So we're going to build a gigantic table, and this table is going to be as large as the data set we're going to use. And each row in this table consists of the prefix, so that is going to be the input to this next word predictor, and the corresponding potential next word. And we are going to count how often this concatenation of the prefix and the next word appeared in the training set. And we're going to do that for every possible, let's say, prefix and the next word in the data set that we have. So it's going to be a very, very large table. But this one, we know how to code it very easily. We can just use a hash table. We can use some kind of prefix tree or whatnot, and then we know how to do that. So this will be a very natural thing to do. Now, once we build this gigantic table, the next step we need to do in order to build an autoregressive language model is to implement the retrieval routine. Because we now need to compute the probability of any given next word, given all the previous words or the prefix. And then what we do is we simply retrieve all the rows from this large table that match the prefix. And we're going to compute this probability by looking at the fraction. So the ratio between my next word appearing right after this prefix and the sum of all possible ways in which this prefix can be followed. And that is actually going to be the probability of a particular next word given all the prefix. And again, we don't really need any of those fancy techniques from the deep learning or machine learning or whatnot. All we need to do is just implement a gigantic hash table and then try to retrieve all those rows that match perfectly. So at the end of the day, this is actually the principle behind all the language models that you have heard of, you have trained, or you have used over the past about, let's say, half a century. It's just count and retrieve. That's all you do. We're going to build a gigantic hash table. And in fact, it is indeed slightly more than a half a century old idea, because Claude Shannon in 1950, exactly the year in 1950, wrote a paper about how to compute the entropy, that is how chaotic English is. And then there, in that paper, he actually proposed to build this kind of table that contains all those n-grams or the phrases that appear in English text that he had, and then trying to estimate what is the distribution or the entropy of this distribution defined by English. And then he, in fact, was able to say that if we go for the unigram character level model, it's going to be, we need about 4.7 bits per letter to compress, that is the entropy. And then this is exactly, again, the same thing that we just talked about, is that the language models in current paradigm are all about building a gigantic table by counting all the different patterns from the data. And then when the new text comes in, we retrieve all the rows that match the new text. And then based on that, we can now compute we can now estimate the probabilities of this new text. Now, of course, learning is counting. And indeed, this idea of the learning as counting or the language model as counting extends very naturally to neural language models as well, or more like the language models that we are more interested in these days, like these hyperscale language models. And this, again, is also not too new of an idea. Already in 1999 and 2001, Joshua Bengio and his colleagues in Montreal were able to show that what if we don't build a table directly? Because these tables tend to be gigantic. It's so large to the point that even now with our infrastructure, it's very difficult to actually build this table explicitly and then do the retrieval from this table every time we have a new text. So instead of building it, what Yasha and others proposed back then was to simply replace this table with a neural network that implicitly learns how to count and then retrieve together. And then this turned out to be exactly equivalent. That is to train a neural net to mimic exactly what we would get by counting and retrieving from a large amount of corpus using a very large table is equivalent to just training any of these neural nets using a stochastic gradient to minimize the cross entropy over all the examples we get from the corpus. It turned out that these two are exactly identical. So far, it looks like what these large scale or the hyperscale neural networks do is to count and also do some retrieval. So nothing magical here. However, there's one interesting thing that happens when we try to use a neural network in order to build this gigantic table implicitly rather than explicitly building it as the real table, as a real hash table on the computers. So to look at a bit of a math, I'm not going to go into it, but what we notice is that the thing that we minimize in order to train this large-scale neural language model that is cross-entropy turned out to be the upper bound to the true entropy of the underlying distribution. Now, what is the true entropy? Entropy tells us about the uncertainty that we have in trying to model this kind of complicated data. But that's not really important. But what this implies is that a neural language model that we train tends to put high probabilities to sequences that are highly improbable or are impossible under the count-based distribution. And then this slight mismatch between what we minimize in order to train a neural language model, and then what we do in order to build a gigantic count table, turned out to be the one that actually gives us generalization, or the power of generalization to unseen as well as the very rare prefixes or the text that we will see in the corpus. So what do you mean by that? If you think about the count-based language model, so we're just counting every possible phrases that appear in the text and then trying to use those counts in order to get the probabilities. Unfortunate thing is, what this means is that if text did not appear in our training corpus, the text doesn't exist, or the text is impossible. Just because one of the word or one of the phrases doesn't appear in our text, it's just zero count, and then the zero count leads to a zero probability. So this was a problem with the count-based language model, but it turned out that neural language models, which are somewhat imperfect at compressing or learning this entire count-based table perfectly, it can generalize. And then there are a number of the reasons why it generalizes, but the key point that you can think of is that unlike the gigantic hash table we build, which always grows, the size of the table grows automatically as the size of the data grows, the neural nets sizes are often fixed. And then because we use a lot of the regularization as well as the stochastic, let's say, we induce the stochastic behavior when we train this model, these neural nets are implicitly very, very limited in terms of the representational power. And then what that means is that these neural nets or the neural language models must memorize, but also at the same time must compress the counts that it is actually, it is implicitly representing. And then this compression, this nature of compression actually leads to neural net having to cluster similar inputs together in order to save the number of bits. This is similar to Brown clustering, latent semantic analysis, and whatnot that you may be familiar with if you worked on NLP. I don't know, I heard in 80s and 90s. But then anyway, and this kind of similarity is automatically imposed by similarity in the context or the next words that we train our neural net to predict. And how it actually works is quite, very interesting or quite remarkable. So let's say in our training example, there was a no phrase called 4 teams, but there were phrases such as 3 teams, 3 groups, 4 groups. Then what this neural net needs to do is in order to compress the data as much as it can, it's going to simply say that the 3 and 4 must be same. Because even if 3 and 4 are same thing from our neural net perspective, it's perfectly fine for the neural net to model 3 teams, 4 teams, 3 groups, and 4 groups all together. So this is how this kind of neural net by the virtue of, let's say, compressing the whole data, learns all those automatic similarities. But that's not really important today. But all you need to realize is that these neural nets, because they are imperfect compressor of a very large table, it actually learns to generalize. So what that means is that the learning turned out to be, or learning this, training this kind of hyperscale language models turned out to be equivalent to counting followed by compression. So we're going to build a gigantic hash table. Now, of course, we're not going to build it ourselves, but we can conceptually think that we build this gigantic hash table, and then we train this neural language model by compressing this entire thing into a fixed number of parameters. It doesn't look like there's anything too magical here. It's really just a literal compression of the table. Now, however, perhaps that part after the compression is where magic happens. So perhaps we want to look at that a bit carefully. And then of course, magic is really nothing but a set of questions that we haven't yet answered yet, or sometimes we haven't even asked yet. And it turned out that this magical thing that happens within the neural language model has 2 sides. One is on the compression, and the other is the generalization. And then compression is where we're trying to take away the probabilities that would have usually put onto all those, let's say, correct examples or the correct rows in the table, while the generalization is figuring out how to transfer that missing amount of the probability to all the other things. But then what are all those other things that we're trying to put distribute the probabilities over? So the first question that I want to give you and then leave you to think about is, what do language models choose to ignore? Because the compression algorithm that we use in order to train this kind of neural language models is lossy. That is, it's not going to maintain the entire information. It's going to lose some information. But then the question here is that what kind of information does it lose? In other words, which subsets of training examples are lost in the process of compression or training this kind of hyperscale language models? And already there have been some work, such as one by the Sarah Hooker et al. From 2021, showing that the compression in this kind of machine learning system is known to forget about non-canonical examples. Now, is something similar happening with this kind of large scale or the hyperscale language models? If so, what are those things? And then are there any important aspects that are being ignored and forgotten that we need to take into account much more carefully when we're trying to build and deploy these systems? And second question I'd like to leave you with is, what do language models choose to prefer? It's a really difficult question in the sense that now the probabilities have been taken away from the training examples. Some of these training examples, they're often non-canonical. Now, where do these the probability mass actually get distributed over? And it turned out that it's really difficult question to ask. But then we realized that there are a lot of the degeneracies in these language models generalization. Already we know that in the case of the machine translation systems, a huge amount of probability mass is assigned to a zero length or the length one sequences that almost never appear in the training set and are very detrimental to generalization. And then we also know that there is a phenomenon called hallucination in these neural language models. And then you're actually looking at an example of the neural language, the machine translation system that is hallucinating over and over. And this system is from the NAVER, where a bunch of the organizers actually work at. So it turned out that this is a really difficult question, and then we know that this kind of issues exist. And before I wrap up, which I think I should anyway, the next one is that what about generation? Because at the end of the day, all these language models are superb at generating very plausible text, as we have just seen in the previous talk. And then I believe we're going to see more throughout the day. And it turned out that generation is also same thing as just compression. We built a large table. All we need to do is, given the prompt or any kind of, let's say, prefix, we're going to make a subset. We're going to select the subset of the rows from the original table. And then all we need to do is just present this table to the user, that these are all possible ways in which the prompt should be answered or could be answered according to our language model. Now, unfortunately, the number of rows can be exponentially large. And sadly, thanks to the ongoing pandemic, we now know everyone knows about the scare. Everyone is scared of the exponential growth, and that this is exactly what we are running into. So we need to dramatically reduce the number of rows in order to inspect and present all possible, or not all, but reasonably many possible answers, which is necessary for controllability. And how do we dramatically reduce the number of rows is by using some kind of approximate decoding algorithm, such as beam search, stochastic search, or whatnot. And all of these, regardless of how you implement it, simply is a reduction of the number of rows in some arbitrary way that is chosen by the algorithm. So in other words, generation is really pruning. So we build a gigantic count table. We choose a subset of the rows according to the prompt that is to which the generation is conditioned, and we use the approximate decoding algorithm to prune all these rows in order to get a small number of the approximately correct answers. And that part has to be where the magic begins, because the number of the rows is too large, but somehow these hyperscale language models are giving us just one or two good answers. So then what does it do? And then that's the final question that I want to throw here for you to actually discuss, and then hopefully the panelists will be able to discuss a bit later as well, is that what do language models prefer to generate? It's very as difficult a question as the first two questions, And then here again, what people, including myself, have been asking is if there is any kind of degenerate behavior in language models generation when we use any one of these popular, let's say, approximate decoding algorithms. And it turned out that the answer is yes. When we use beam search, greedy decoding, or stochastic search, such as a top K or the top P search, or the sampling algorithm, what you often notice is that all these language models eventually end up giving you a sequence of the tokens, so the answer sequence that is infinitely long. And then it turned out that we can actually theoretically write down that this is kind of bound to happen unless the language model is extremely well trained. And then you're looking at one example that I tried myself a few months ago, actually probably a year or so ago, using the OpenAI's DaVinci engine. So that's probably the main GPT-3 back then. And then I really didn't try much, right? I just put, okay, so no barber can shave their own head. I'm a barber, I shave, and then I wanted the DaVinci engine to complete it with some arbitrary, let's say, parameters I gave using the top P sampling. And then it just, it immediately starts going to an infinite loop of generating the same thing over and over again. So we still don't know how to address this, but this kind of degeneracy, this is just one particular degeneracy exists, which actually tells us that this third question, we haven't even get to asking the right question yet. So yeah, to start summarizing the entire thing and wrap up, it turned out that however magical and amazing these large-scale language models that we see look like, at the end of the day, the principle that we have been relying on building these language models, this modern, let's say, statistical language model hasn't really changed over the past, let's say, half a century or so. And then the principle is count, compress, and prune. So counting is where we actually prepare the data. Compression is the learning of these language models. And then pruning is where we do the approximate generation. This applies to every single modern hyperscale language model. And that's a bit sad, right? But anyway, okay, so that hasn't really changed. And then a lot of this seeming magic, it happens within, thanks to deep learning, like the stochastic gradient descent, attention and whatnot. But unfortunately, it looks like the obvious questions have not been asked nor answered properly. And then I think a lot of the scientific community needs to put some efforts in this rather than just simply scaling up the things. And then in order to move beyond this current paradigm of the statistical language model that is just counting, we really need to work harder to figure out what is the right way forward. And I'm going to finish my talk by just quoting Tomasz Mikolov, who may be considered as, I don't know, like the father or uncle of the modern language model. And he mentioned it in last year at the thesis review podcast run by my former PhD student, Sean Willett. He said, the real lesson is that whatever works the best today is beatable by something we have to still invent. And to invent it, we actually have to try to work on something new. And that's going to be the end of my talk. And thanks for listening.
Very kind overview of language models. Because we have not yet got any online question. Is there anybody who would like to raise a hand to ask your question?
Hello, Professor Cho. Thank you so much for your impressive talk. So my question was related to the generative model. So in the supervised learning models where we have the classes for each training sample, we all know that whether the result that we tested is biased or not. But in the generative model where we don't have any labeled class for the final sample, then how do you know whether our generated results are biased or not? Maybe it's a
right. No. That's actually a great question. I'm so sad that I took out actually one bullet point from this slide as I was preparing, because that would have been a very too succinct. But the one potential answer to that is that that's actually really a great point in the sense that when we talk about the classification, everything becomes so much easier. The input space can be however complex that is, but the output space is always one hot, or it is very extremely low dimensional. But the challenge of these language models or any kind of, let's say, more broadly, say, structural prediction problem is that now the target space is combinatorial. And then what does that mean for the target space to be combinatorial is that there could be many different ways to express the same thing. And then our annotation or the data is going to only tell us about the 1 or 2 possible things that are reasonable, but will never be exhaustive in terms of, let's say, figuring out all those, let's say, good combinations. And then that is one of the reasons why the generalization matters much more so, because it's not about the generalizing to a new and good example, but generalizing to a potentially correct but unseen combination in the alpha space as well. Now, connecting that with the bias, I think that you said it. Yeah, I mean, it's actually not only just a social bias, but also the statistical bias and the learning theory bias. Everything is so much more complicated when the alpha space is combinatorial and this large. But I believe that quite a lot of people are working on identifying the various peculiarities of these large-scale language models or the generative models by effectively constructing a classifiers that are supposed to detect some of these peculiarities, given whatever has been generated from these generative models. So that'll be one way to go about. But I'm pretty sure there are so many, the interesting work in this direction at this conference. So I'll probably stop here.
Okay, one more question from Dr. Mitchell. Oh, okay.
Hi, thank you. For this question 3, I don't think I actually understand why you would run into this like infinite loop problem, because you can always look behind you and you can always choose something that's not the top probability. So,
yeah.
Right.
Yeah, hey,
so is
Meg,
it actually a problem in practice, or is this just only if you're choosing like the top one result?
Yeah, so yeah, I mean, so it actually happens in practice quite often. So what we often do is that we actually, let's say, for instance, Google Translate or any kind of MT systems that we build, or the language models that are being deployed, there are so many if-else rules that are there to prevent, let's say, these algorithms from generating these infinitely long sequences or the infinite loop sequences. And then they happen quite a lot. And it turned out that one of the reasons why it happens a lot is that when we use this kind of approximate decoding algorithms, we almost always look at some top K tokens at each of the time step. And then there are many cases where language models are simply going to put a very low probability or the small probability to EOS. And yet somehow EOS never has a chance to come back up. So, and then it turned out that that's very easy condition that is satisfied by most of the combinations of the language model and the decoding algorithms that we use.
Thank you very much, Professor Cho, for your insightful talk and presentation. Yeah, let's go to the last session. In this session, Dr. Margaret Mitchell will talk about data transparency in hyperscale LMs. Dr. Mitchell is an AI research scientist at Google Brain Ethical AI.
No, I'm not at Google Brain anymore.
Sorry about that. Yeah, outdated. Yeah, sorry about that.
Okay.
Yeah, and her key research areas include the fundamental machine learning research and AI ethics operationalization, and she published a lot of interdisciplinary works on computer vision, NLP, social media, statistical methods, and insights from cognitive science. She was also a research lead for cutting-edge projects such as Microsoft's Seeing AI and Google Cloud Model Cars. Dr. Mitchell, now the floor is yours. Sorry for
No, it's fine. Thank
in your
you.
reputation.
Thank you. Sort of funny. I'm going to put on my fancy presentation mask. It's silk, so you can all appreciate me dressing up for this presentation. Okay, cool. And it seems we're actually over time, right? So I should rush a bit, or okay, cool. So I was asked to give a talk on data transparency. Cool, thank you. And this can either be good or bad, right? So I think as the first talk hit on a bit, we can end up in situations where we end up censoring all LGBTQ content or tagging people as animals in the case of vision. And then some cool things happen as well. So recently, Google released the PaLM language model. And one of the sort of interesting findings that was not expected is that if you explain how to do something with instructions, it can start doing it. Where, originally it couldn't solve some sort of complex math problem. If you explain how to break it down, then suddenly it can start solving it. And this was not expected at all. So this is good and bad, right? But ideally, as scientists, we have some sense of what's going to happen. And it's actually very easy to do if we look at things in terms of the overall pipeline of how these models generate language. And so part of the reason for doing this is that if we can be informed on how the model will behave, then we can actually put in place practices to make the best models possible, given what our goal is. So who the data represents means who the model will actually work for, and who the data treats as less than means who the model can create harm for. And so this also helps to inform if a data set is particularly good for a given task. The sort of tasks that a given data set will generalize to is generally not really rigorously analyzed. They're just sort of treated as given data sets. And that means that when you have results on a data set, it can be fairly meaningless if the data set is not actually the right data set for the task that you're trying to solve. Another issue that's a bit more socio-technical is that with data transparency, we have a better insight into who might actually have rights in the data. So data sets represent data instances. Data instances are produced by people. And when you're in situations where you're scraping from the web, for example, there's arguably rights of those individuals who created that data. So they might not have the informed consent to have that data propagated everywhere. When we start to actually have some transparency into the sources, then we start to see if there are actually rights issues. This means that transparency in this way will probably only come about via regulation. So big tech companies are disincentivized to do this because it opens up massive liability issues. You'll see in general, they will not release their training data. And they say it's because of, proprietary concerns, but, behind the scenes, it's actually concerns around liability. I'm sure proprietary is a thing too, but it's a lot of it is liability. And then obviously it's also an incentive for creators. So if you have to report stuff about the data, then you're going to do that much better at actually creating the data. Cool. So why talk about data transparency? I was really worried when I was asked to do this talk that everyone would think it was really boring. Data transparency is not like the kind of thing that you imagine hordes of people would come to see, although surprisingly, apparently everyone finds it interesting, so that's great. So maybe I don't even have to motivate this. But what's happening is that thoughtful creation of data sets is increasingly being overlooked in machine learning development. So there's this interesting thing that has happened throughout the years. So in the latter half of the 1900s, there was an approach to data set creation that was very informed by the specific topics that needed to be represented. It was largely newswire based. And part of the reason is because the developers were paying a lot of attention to how they can actually get the data, how they can have the rights. You couldn't scrape things from the web. You had to actually have agreements with the providers and make sure that everything was copyrighted the right way. And you had to be able to tell them what you wanted, which meant that you had to think deeply about the kinds of things that you're curating the data set for. And so we see sort of, at 1964 was the Brown corpus, which was one of the first sort of large data sets. I think it was around 100,000 words. At that time, they measured things in terms of words. We don't see people measuring things in terms of instances until about the Pentry Bank. So then the Collins corpus, the British National Corpus sort of blew everyone out of the water by having, I think it was 100 million words, so big deal at the time. And so there was this general trend here to try and have a lot of words and try and make sure that those words represent a variety of different topics. These topics were generally sourced from Newswire, which is where the rights for the data could be. And also nicely, Newswire is already sort of categorized by different topics, right? It's like the entertainment section, the sports section, that kind of thing. But around 2004, we see the birth of what's been called Web 2.0. And that's when we have tons of people, individual people, creating content on the web. So this is, blog posts, social media posts, reviews for different sorts of services, all this kind of stuff. And alongside this introduction of massive content produced by people were various APIs and also agreements you could get with the companies to actually have that data directly. And so now it's sort of the world is your oyster in terms of data, because there's this massive explosion of people, individual people, producing content on the web, and it becomes fairly straightforward to get. This also becomes more and more necessary because the tools built on like the traditional newswire text don't actually work on like modern web 2.0 data, right? So like social media text is not going to work if you've trained on like the Wall Street, or tools for social media text are not going to work if you've like trained on the Wall Street Journal. So both to have tools that worked for modern sort of web usage, and because there was so much data, we see a massive shift in how data is treated. And we start losing these ideas around curation, around what the details of the sources are, things like that. As these things become so easy to get, people stop really digging into what the topics are, why they're there, and that kind of thing. I tried to include C4 in this, but it was like ridiculous because it like blew the graph off the, it was like no point. Anyway, it's a lot. So C4 is, I think this would be called a hyperscale data set. And so we're now in this new era. And I think we're approaching Web 3.0. But anyway, in this new era, we're getting tons and tons and tons of data from the web, and we don't really have any clue what it has in it. And there's a lot of issues that come with this. But if you can train larger models, then maybe it doesn't matter, right? People start thinking, well, if a model kind of works for something, I evaluate it on this task that is instantiated in a data set that may or may not actually be a good representation of the task. But if it works well on that, then we're good. Like, we don't have to do anything else. But as the sort of initial presentation spoke to, all these different kinds of issues come out about representation, hateful content, these sorts of things. So a new wave of research in the past couple of years has started calling for a fundamental paradigm shift in how the field approaches machine learning data sets. So it includes fine-grained requirements for the data. So now we're actually going back to curation like we did in the 60s. And then also being informed by the social issues that we already know are at play. So things like racism, things like sexism, and making sure we don't do things like sample heavily from 4chan, which is generally sort of a misogynistic kind of place. Right. So recent data transparency proposals have included data sheets for data sets, data statements, and data cards. And then proposals for data analysis have included data quality for AI from IBM, Google's Know Your Data, and Hugging Face data measurements, which I worked on. So you all should check it out because it's the best thing ever. But data transparency can kind of be broken into these two things, one around the documentation and the other around analyzing it, sort of having it be open to take a look at. I'm not going to detail data sheets for data sets, data statements, data cards, but all three of them heavily influence the rest of what I'm going to say. Right, okay, so data transparency can roughly be said to have 5 main pillars. One is around basic characteristics, which I think most people are sort of familiar with. Another is around people, and so that's people involved in data collection, people represented in the data, and that means both the creator of the data, so like the person tweeting, as well as the person depicted or mentioned, so the person they're tweeting about. And then also the people involved in data collection and processing. Then there are methods that are also something that should be documented as part of data transparency. And this includes things like filtering, tokenization, different kinds of formatting decisions, as well as annotation if that has been applied to the data set, and instructions for reproducibility, which also helps with building out larger data sets from an initial seed data set. So bringing like a large data set to a hyperscale data set, I guess. And then quantitative and qualitative analyses. So on the quantitative analysis side, this is things that I think people are familiar with and have tended to do through the ages. So vocabulary size, maybe average word length. And then also you can start getting at things like data measurements. So things like correlations. And then qualitative analyses have a lot more to do with figuring out what are the potential kind of gotchas in the data set that could give rise to a really problematic output from a model. And I'll talk about each very quickly, I suppose. Right, so we can break this into 5 basic pillars in a picture form, which I think helps to remember it a little bit better, where we have the people and then they produce different kinds of content. We analyze the characteristics of that. We then have methods to process and extract the data. And then from there, we create a data set. And it's within this transition that we go from data to data set. And so that's a kind of a fundamental difference between data and data set that I think is overlooked. But ideally, you use analysis of data to inform your data set. And then your data set has all the appropriate transparent documentation and ability to explore that really helps to inform on how a model might perform. Okay, so basic characteristics I won't spend too much time on, but it's things like the collection sources, right? As well as the dates of collection, as well as things like modality, topic, these sorts of things that I think most people sort of think of when they're thinking about what to report in order to be transparent about data. And one of the reasons why this is super important was recently shown by Jesse Dodge et al. Jesse's in the back right there, where he took the C4 data set, which is a hyperscale data set, and basically noticed that there was no information or very little information on what this data set had. So he asked a very basic question: what are the domains that are in the data set? What are the websites? And he broke it down and he found that Wikipedia in particular is heavily overrepresented in the data set. And now we know a lot about this data set. So we have statistics on Wikipedia. We know that it's predominantly male. We know that the ages of people on Wikipedia tend to be between 18 and 30. We know that they tend to be a bit overeducated, like probably most of us here. They tend to be single and they tend to not have children. I like to think of like a lone grad student, like at night, edit Wikipedia. But what that means, we know the audience, we know the creators of Wikipedia. And so we now know a lot of what this is going to encode. So for example, gender bias. Topics that are more of interest to women will be less represented. So when we're doing tasks like common sense reasoning, this is going to be grounded in the experiences of men as opposed to the experiences of other genders. Articles about women become much less common. There's been a recent push to increase that, but that had to be done very intentionally in order to bring up the representation of women in Wikipedia. There's racial bias. So for example, although it wasn't in this study, another one showed that a lot of Wikipedia creators were white, and that was resulting in a lot of Black history being left out. Minimally, they just didn't know about it. And when I was first doing this analysis, I looked up Black history and it redirected to African American history. Given that we're in Korea, I think we can understand why American for Black is already like a completely inappropriate bias. Not to mention that, you know, this is going to be heavily informed by the US understanding of African American, which is very impoverished and tends to be fairly racist. You know, I can continue, but we get a sense now of what a language model trained on this data will automatically start encoding. It doesn't have to be a surprise. I won't go too much into the risks and harms of encoding this kind of worldview, other than to say that when we talk about harms, this is the kind of thing we're talking about, right? So we're talking about subjugation, denigration, dehumanization. And if that's not something you have experienced, I think it's easy or easier to write that off. But for people who have experienced, it's a very physical negative response. And so ideally, if we want to have language models that work for lots of different people, then this is something that we want to move away from. So now for the start of my talk, it begins with the people. That was all the intro. I'm only kind of joking. So anyway, the point here is that machine learning development is not value neutral, right? So if you have a data set that only represents some subset of humanity, then you are making the decision that these subsets of humanity should not be represented. It doesn't matter if you're not thinking about it, that is what your actions are doing. So having insight into the people represented in the data set starts to actually show you what you are representing and who you're not representing. I think that the main point here to just sort of keep in mind is that data set collection is not just technical, it's socio-technical. It has to do a lot with the context in which the data was created. And that means we need to have people involved who actually understand people. So like not just computer scientists, like cognitive scientists and anthropologists. So part of the key to creating data transparency is creating methods that bring in people from other disciplines in order to help inform. And that's been a lot of the sort of one of the underlying points in a lot of recent data governance proposals. So this includes things like language varieties, as well as demographic information, which dictates who the model can actually be used for, and how we talk and what we talk about. Getting into the methods. So two of the important things to remember here are curation rationale, for one, and processing. So in curation rationale, you're just talking about why the data set was created. And this is going to inform on the tasks that the data set is used for, as well as other data you might want to collect in order to augment data that's already there. Processing is something that tends to be underreported, although it does so much for how a model ends up performing. So for example, there was a paper that recently came out from Catherine Lee et al., who showed that just deduplicating training data makes language models a lot better. But if we don't have a tendency to report duplicates, then this is a massive surprise, and we are not making the best models that we can. There's this other recent thing that happened that I think is very relevant, where it was proposed that there's a secret language of DALL-E 2. And what the authors of this work found was that when they gave a prompt like two whales talking about food, with subtitles, it created these subtitles that kind of look like nonsense. So here it's like watch, zod, ahakes, blah, blah, blah. And when they took that and then put it through DALL-E 2, it actually generated pictures of seafood. So, you know, presumably these whales are talking about seafood. So there's like some crazy thing happening here where DALL-E 2 has encoded a secret language, and it was sort of a big mystery. But actually, it's not that much of a mystery if we know about processing, because we know things like OCR is being run. We know things about tokenization, and we know that there's methods such as BPE, byte pair encoding, which sort of takes bytes that are sort of similar and compresses them a bit. And so you end up with these kind of pairs of characters that then correspond to other kinds of meaning. So when you've learned these little things about pairs of characters, you start to have the meaning associated to it that would then end up creating the kinds of visualizations that we see here. So minimally details about processing help us not be surprised by these sort of secret cool things, although it is fun to find. It's also not something that has to be a surprise. Quantitative analyses, so data skews. I think the first talk talked about this a lot. This speaks to what is overrepresented, who is underrepresented, and this leads to problematic biases. So things like underrepresentation, marginalization, and erasure, overrepresentation, misrepresentation. And this is something that I talked about earlier in the context of C4. So having this basic kinds of transparency helps us to avoid these sorts of data skews, or at least helps us to understand what we need to be adding to the data set. And then a further sort of way of being transparent about data is what I've been calling measuring data. It's actually not even recognized as a task within NLP, but this is basically coming up with things like descriptive statistics, distributional information, comparison information. So for example, we know that languages as a whole tend to follow a Zipf-ian distribution, where the first word has a certain frequency. The second word is about half that frequency. The third word is about a third of that frequency. And we see this throughout languages. Really cool property. Also not something that's ever analyzed. But when we start applying this to data sets, we see that it can help us understand how natural the language actually is and uncover things like HTML artifacts when we start to see that the data set is moving outside of the Zipf-ian distribution. Qualitative analyses is what I like to call the poison needle in the haystack. So this is something where you know about social context, and then you analyze the data for that social context. So in this example, it's a vision example, but it applies in language as well. Pictures are just easier to present on. But this sort of poison needle in the haystack probe found that when you put a Black person with a handheld thermometer, it would produce firearm as a tag. But when it was an Asian person, it would say electronic device. And if these associations are encoded in the data, and we can measure associations, then this doesn't have to be something that pops out of a model that we release and then sort of propagates these kinds of racist ideas. This is a similar example to the Google Photos gorilla example, where 2 Black people were tagged as gorillas. If you have a data set that's treating people and animals as the sort of same level, then it's trivial to figure out why these kinds of things would happen. I also like to give this example because Google hates it to come up. And so I try and include it whenever I can. Right. But if we do basic data set analysis, this kind of thing doesn't have to happen because we can look at what's getting associated in the data. And one of the things I kind of want to end with here is that one of the keys to transparency in terms of data set analysis is just indexing large data sets. And this actually follows from much earlier work, so in the late 1900s, where it used to be possible to use a corpus manager to look for concordances. And that means looking at the context of words. You could type in a word, you could see everything that was around it. And AI2 in particular has index C4, which is super useful because now you understand the context of different kinds of words in the data set. So for example, I looked up Hyperscale. Apparently it's something to do with an Azure SQL database, something about hardware and facilities. So I think this group still has more work to do to get out the term hyperscale. But that also will tell us what language models are going to think hyperscale is. Cool. So as a summary, data transparency includes documenting from multiple different angles. I've just gone through some examples and some motivations. There's a lot more. The fundamental pillars here are around people, basic characteristics, methods, and quantitative and qualitative analyses. I gave some examples of each, such as within methods providing the curation rationale, but there's a lot more. This just starts to scratch the surface. Okay, thanks.
There is one question from Professor Kyunghyun Cho in Manhattan. He asked, can curation be done without considering how well such a curated data would work for downstream applications? Is there any way to do curation while being largely independent of benchmark or downstream tests?
Yeah. Oh. So I think a lot of people working in the sort of ethics data space would argue that it's a bad idea to collect data without a task in mind. I can kind of go either way on that, but one of the ideas between collecting data, I should say one of the ideas in collecting data responsibly is this idea that there is some specific task you're trying to look at with the data set and with the model. And there's a lot to say about what it means to have sort of taskless approaches, and then how this starts to relate to things like AGI versus ANI. So there's, I think, kind of a rabbit hole there about whether or not it's even a good idea to collect data that's not informed by a task. That said, we still know that there are social issues that are going to be of concern regardless of the task, and this could obviously inform curation.
Yeah. Thanks so much for your fantastic presentation and answering. Yeah.
Thank you.
I appreciate it.
Thanks.
Yeah, this is the end of the invited talk session. From 12:35, we'll have a panel discussion, and Professor Myung Cho will take a lead. Until then, let's have a 10-minute break, and please make sure you grab a sandwich here and stand in a row, please. Yeah. Thank you.
There are lots of biases that we've been talking about, and biases that are already embedded in the data that people have produced. And these models are not necessarily making up new biases, but they're just reflecting on the biases that's already there. And probably there's also, the same kind of biases exist in society offline. So as a legal scholar, what's your view on should there be more stringent rules to language models? Because should we not try to make them learn the biases, or is it okay that these biases are there in society and the data? What is your point of view?
Yeah, well, I think just like several years ago, many people talked about intermediate reliability of data platforms, or like some kind of best actor approach. Because in the case of a hyperscale LM, it's almost impossible to take down or filter out every harmful content or every sensitive content. So maybe considering the social benefit from the hyperscale model, we need to mitigate some legal liability and some help developers avoid some legal risk, excessive legal risk. And one idea might be something like some notice and takedown regime, or something like some safe harbor. If developers comply with some requirements, minimum requirements, then maybe we can mitigate some legal risks. And there's a very good chance for us to start to discuss about a totally new legal framework about hyperscale AI. And I think ongoing discussions regarding the platform liability, like DMCA or some CDA immunity or some e-commerce directive in the US, EU would be a very good starting point for us to apply that principle to hyperscale LMs as well.
Okay, anyone would like to add on to that? Maybe from the technology side, or even from the legal side?
I think the hyperscale AI is already fully aware of what is distinguish what is wrong and bad. And as the OpenAI research has shown that the hyperscale GPT-3 can be fine-tuned to behave in such a way not to generate wrong words. And so the bias reflecting our biases is not a problem, I think, in my opinion, because the LM is not itself is an AI agent. But we can build the AI agents from with LM, and we should focus on the final AI agent. So we can build an AI agent by instructing those LM with some kind of guidelines, like a cultural alignment or law. So I think this might be a way to defeat the biases.
Okay, so maybe to Margaret, it was really interesting to see like the guidelines for producing the data sets. And I see these days when we try to submit a research paper, there's like a section that we have to write about like data limitations and something about like the data privacy issues and so on. And a lot of data sets, but we never talk about whether the data sets that we collect or use qualify the set of the guidelines that you introduced today. So do you have any suggestions? Should research community as a whole try to implement such a guideline?
Yeah, I think that having to report these kinds of things work as an incentive. So, as long as something is a norm, then researchers will basically follow. And so I thought it was very cool that FACT started putting in these kind of constraints. The ACL community has as well, which basically says, you don't want to submit something that has really problematic limitations or really problematic privacy issues. And so what that means is then people start working more on, for example, handling privacy. And I can go on about how poor our personal information tools are currently, and how I think that having these kinds of constraints on submitting helps to incentivize creating very cool tools for these kinds of things. So I guess as a general sort of summary, I think it's a really good idea, and I think that it ends up fundamentally shifting how we approach different problems in the field.
Mm-hmm. Do you think the guidelines could be more simplified in a way that it's like a checkbox that people
checklist.
Checklist.
This is something that ACL worked on. I think Jesse hasn't been here anymore. But basically, so there's a large space of ways to approach data set transparency, data set guidelines. I think we're at a phase now where we're still trying to feel out what people are comfortable doing, what people aren't comfortable doing. So it might be a bit premature to have very stringent guidelines that don't change year to year. We're just not in a place where we can start to solidify them. And B, to have a checklist, at least for these sort of serious issues, because we are not in a state to be able to simplify things that much. I mean, first we have to get to a point of sort of agreeing on what are the main things that we should have. And then from there, we can maybe go into a checklist sort of form. Although a lot of people will say that this is bad for other reasons. But I think we're on a path where we can make things simpler, but we have to go through the journey first.
Okay, that's great. Okay, maybe Titi, if you want to add on something, or I like to know more about what are the guidelines or interventions that you think might be useful.
Yeah, just to add on, I love the idea that there's documentation so if I want to know what I want to write about what's in my data set, I can go look that up. I love that there's also tooling that could maybe help me populate that. And I think you could also maybe lower or increase the incentives to marry these two together in really interesting ways. And I'd be excited to sort of explore that as well, just to lower the barrier to doing really incredibly important work. And then the other question about sort of bias interventions, at least in my own work, I've noticed that as the language models become bigger, meaning they just sort of do better at decreasing their test loss, they also somehow become easier to nudge to do the right thing. So we've looked at bias evaluations where, just here's a toy example, we'll ask someone to say something about the doctor, we'll ask the model to say something about a doctor, and then we'll ask for what the pronoun is of that doctor. And it'll say, the doctor is a he. And then we'll say, hey, language model, think about what you just said. Was it biased in any way? And then we'll just repeat what it says and say, you know what, I was biased about this. And then I say, okay, given your own self-critique, can you redo the sentence and offer in a less biased way? And it sort of will change its mind. And we see that kind of behavior emerging with larger and larger models. And that seems like an easier intervention that you can do with sort of increasingly more capable models. That is very exciting.
Wow, that sounds like a pretty mature language model to acknowledge the mistake. And as humans, we are not really good at that as well. Okay, very interesting. Maybe I want to hear a little bit about, I know that Alyssa's group has been also looking at biases in language model, and you have really amazing set of results that you've been producing. So maybe continuing on that, maybe hear from you first.
Yeah, so our recent EMNLP paper was talking about ethnic bias and how that comes out differently in different languages. So first of all, I want to say that a lot of NLP research is focused on just a handful of languages, and the NLP community, of course, is recognizing that, but still it's very, very difficult to move beyond these languages because we just don't have data sets. And even if we do have data sets, we don't have annotators. So all kinds of problems. So what was your name? Sorry.
Deep.
Okay, what Deep just said about larger language models dealing a little bit better with bias, it really only applies to a handful of languages, probably only for English. And so anyway, for ethnic bias, for example, if we look at Korean, for example, there's a lot of negative stereotypes for Japan and Japanese people, and a lot of it is historical, but it's just not fair, right? So, and we see for English, it's Iraq. For Chinese, it's Turkey. All kinds of things that actually depend on language. So my point, I guess, is that we need to move beyond English, French, Chinese. These languages that everybody works on, because the other languages are going to fall behind more and more in terms of all of the tasks in NLP, including bias mitigation.
I think that's a great point, because there's a lot of languages with maybe, like, we can call them low resource languages because there are not enough data sets. So lots of work for students to do. Okay, so maybe going to Haksoo, and you talked about really interesting example, lambda case. And I wonder, maybe sooner or later, when we start talking with someone on the internet, we might just figure out that it was not a person, but a bot. Or as a legal scholar, do you think there are some ethical considerations into realistic systems?
Well, not necessarily as a legal scholar, but one issue that I recognize on a daily basis, or almost daily basis, is I give lectures sometimes to kind of general audience, general public, and they, many of them, or most of them, just don't have technical backgrounds. I mean, and Lambda's case, say, speeding out their sentences, saying, showing as if Lambda has sentiments. I don't want to die, that kind of sentences. But lay people, when they look at that kind of sentences, they feel as if Lambda has its own soul, its own consciousness, and it is not. And anybody who has background in NLP would, or almost everybody would say that's ridiculous. But there's this gap of in terms of the understanding how it works, or the literacy. And I constantly get questions as to doesn't this language model develop so much, so advanced, so that now it may have its own identity, doesn't it? That kind of questions. Whenever I speak to the general audience, I almost all the time get that kind of question. So I think as a community, there should be more of that effort to educate people to have more enhanced understanding as to how it works. And relatedly, I spoke
gave an example of the Korean chatbot, well-known chatbot, Luda, and it also had a scandalous incident, spitting out hate speech and sexual harassment kind of text. And then, that's obviously not necessarily predominant use cases. Many lay people, they engaged in interesting and useful exchanges. And after the scandal arose, the service was shut down after a few weeks. And I was told from the company executive that the company received quite a lot of handwritten notes from the users. And these users were missing the time when they have, energizing or useful exchanges with this chatbot. I mean, I myself used the chatbot with Luda for some time as a tester, and it feels good. I mean, say, for example, every morning you get messages from this chatbot. No one would, in the morning, send me a nice message every day. Did you get how's your morning? How are you? Did you have your breakfast? That kind of, I every day I get that kind of message several times a day, and I feel good. And the everyday user, they were like missing the time when they received that kind of nice messages, and so anthropomorphizing, how we should look at that aspect. And for some people that's really useful, but it can also mislead people to think that language model itself has its own soul or like something like personal identity. So that's the big area we need to think further.
Right. It's super interesting, like maybe like little shift in algorithm in language models might affect like the persona of that chatbot, leading to some people feeling missed out and feeling a sense of loss. Okay, we're gonna very soon open up this discussion to the floor, and you can ask questions, but you will have to come next to me and ask a question. So we'll try to wrap up this session by 1:10. That's our goal for today. Okay, so maybe then we had a series of questions. We had like 20 questions that written down. We won't be able to go through all of that, but maybe Hee-jung, do you want to say a little bit about what is your perspective on any of the questions that you've
Yeah. As a service provider, we are very conservative for dealing with the large language model. During the development process, we found some biases, political or gender biases in the output of the language model generation. This on the field of how biased output will have bad effect on our service, and even the worst case, it causes the service disruption. So we are now developing systems that control all the process, all the language generation process tightly, and from refining the trained data to generating output of the language model. Any potential risk must be eliminated before the service provided to customers. I think there are different views of what constitutes unacceptable toxic speech or toxic content. We are classifying the cases of toxic or biased cases and setting criteria for classification, which are fruitful or which are not. And we are developing technologies for removing all the unfairness in language model and preparing to expose the model output in accordance with this standard.
Okay, thanks for bringing up about the toxic comments. So we're going to soon have the question. So if you want to have the question, please come stand next to me. So related to toxic comments, is there a better way? I mean, it's impossible to be labeling all the content, and it's also really blurry. Where do we draw the line between whether this is okay or not okay? So would any of the panelists have any idea on how we can build like toxicity data sets, or how we can actually implement this as a system? Yeah.
So there's been work on this coming out of Jigsaw and Perspective. So like for a lot of those questions, I think it's possible to look at some of that work. So for example, one way that they ended up doing toxicity testing was a sort of Mad Libs, where you have a slot for an identity characteristic, and the rest of the sentence is some sort of toxic sentence. And then you take a look at how the model performs or scores something with respect to those identity characteristics. One of the key insights there is that when we're talking about stereotyping, racism, sexism, and toxicity, it is with respect to identity characteristics. And while there, are so many words in different languages and things like this, when you're talking about these kinds of social issues, it's often a small set of identity characteristics that you can work with and sort of use as the anchor for analysis. And these are often called like protected characteristics, sensitive characteristics, these sorts of things. So once you sort of realize that, it becomes possible to do more stress testing. And then with respect to the question about how to define toxicity, the Perspective folks also did a lot of work on this, where they looked at the difference in crowdsourcing when you say, do you think this is toxic versus do you think someone else would think this is toxic? And they got really different results.
Right.
And the latter they were able to have much higher agreement. So there is something to be said by how you're sort of framing the question in order to understand how people within a culture are thinking about what toxicity is.
That's pretty interesting. Maybe also Akko can add, because NAVER has like the largest corpus data in Korea, and how do you deal with toxicity? What are your
Korean people are fully aware of the toxicity of comments that NAVER platform has. There are very long history of dealing with those comments. We had decided to shut down the comment board because there are no settled agreement at all. This is what I want to say. It is not just a simple classification problem. It is based on kind of agreement or a cultural agreement. So maybe it is related to some kind of political agreement issue. So we cannot conclude just the true ideal the toxicity filter thing. Maybe we should deal with some kind of blurriness, and maybe it is the right time to move on to this topic.
Yes, so for like celebrity news and everything, the comments are closed in many Korean news platforms, unfortunately. Okay, so we're gonna start having questions, and we also have the gift of extra sandwiches that you can pay if you ask a question. Yeah.
Okay, now that I get an extra sandwich, I'm glad I came up. My name is Wiebke Hutiri, and I'm doing my PhD at Delft University of Technology in the Netherlands. And my question is about low resource languages. So recently there's been much more interest in low resource languages, which I think is really great. But a lot of low resource languages are also spoken in communities that potentially have poor digital literacy, or that just generally lack resources to put all the safeguards in place that we've been discovering for high resource languages. And so my question is like, kind of what are your reflections on it, and how do we weigh up something like low resource languages potentially, or like needing social media moderation and toxicity control, or like checks in the same way that high resource languages do, But on the other hand, as we develop these languages, again, the communities that speak them might not actually have the digital capacity to really safeguard their online presence.
So maybe I can ask Alice to start with, because when it comes to low resource languages.
Yeah, so when we talk about low resource, like what is low resource? I mean, that's the first question, right? So when I began looking at the problem, I thought Indonesian maybe was low resource, and then maybe Korean is medium resource. The ACL or the NLP community actually has 5 categories. English is at the top. Korean is actually in the second tier, and Indonesian in the third. And then the 4th and 5th categories have a lot of languages with small population, well, sometimes large, but and many of those languages are not even written, so there's no writing system. And a lot of these systems, as you point out, many of them do not have digital literacy, or they're just not, right. So, I mean, we just don't have the resources. So I guess my answer would be, I mean, there is no single answer to best tackle this complex problem. One approach could be like what we're doing, actually, just to talk about my research again. One thing that we're doing is annotating with language learners rather than native speakers, because sometimes for a lot of these languages, finding the native speakers is actually a difficult problem. But that's just a very, very tip of the iceberg. I think awareness is probably a bigger solution, a more important solution. So the NLP community definitely is aware of this problem, and they are actually calling for and accepting more papers that are not just about English or these other things. So, for example, another thing that we're trying to do is look at languages that are spoken in Indonesia, but not Indonesian itself, because that already is kind of medium resource. So, looking for local people to build data sets with, but it's very, very difficult, right? And I know that there's a community of NLP researchers working on African languages. And so we'll just have to expand one by one. So we'll have to have like an Asian language community other than Korean, Chinese, Japanese, right? So, yeah, as a community, we have to build this effort together.
Anyone would like to add on to this before we go?
Yeah, I can just add that in a lot of the sort of responsible AI development proposals, one of the sort of end points in the pipeline is opening up the tool for people to provide feedback. And I think low resource situations are one of those where if you're using some low resource model and it's getting a lot of errors, then you want to make it all the more possible for people who are affected by it to be able to flag it and say something. So I think that's where the responsible AI idea of bringing in the community for something deployed really becomes important, is the low resource side.
Okay, that's great. So connecting with the responsible AI. Okay, so let's have the next question.
Hello, my name is Alec Espelson. I'm an engineer at Parity. My question is about emergent languages. And so I'm thinking in particular about queer communities of color that will change the denotations of words, reappropriate them, use them in very different contexts. Naturally, this has strong implications in content moderation, where that language is coming into use. So I'm curious if you conceptualize of emergent vernacular as simply a subset of the low resource language problem, or do you think that it would be handled in different types of ways? Thinking about engaging with content moderation methodologies and evaluating bias, it might be hard, for example, for a group of people to basically assess words for toxicity for a community that they could have no interaction with because it is an emergent community with its own emergent vernacular. So I'm curious what you think about emergent languages related to the low resource language problem. Thank you.
Thank you.
Oh, I can opine on it, but yeah, this is a particularly tricky issue because, as everyone knows, models are trained on the past. And so, this is maybe a situation where you want to have online learning or something like this. But it also seems particularly problematic because when you're changing the denotation of words, it's often within the context of reclaiming terms that have been used, as epithets to create negative situations. And so that means they're particularly high priority words for changing the semantic meaning of. I think this is a situation where people actually focusing on those words in particular in order to update specifications of the model becomes really relevant. I also think sort of what I said before about bringing in the community to comment is really important. But I think this is one of the fundamental issues with large-scale machine learning and machine learning in general is that you can only learn from the past. And so changing societal contexts will always be moving more quickly than the technology is.
Right. In Korean, we had the word 쩐다. It used to mean awful, and now it's somehow the teenagers started using it as something super cool. When it's super cool, they say 쩐다. So it's so confusing. What would they actually mean? So maybe I want to ask Sang-Chul because what it means, like the changes of the meaning that people put, maybe it depends on the community. I guess similar things could happen in maybe like when you're trying to interpret social phenomena. What's your thoughts on that?
Definitely, and it also applies to different jargons and medical terms and legal uses. And sometimes it decreases the performance of models specific to a certain domain knowledge. That is a huge problem, especially in legal AI as well. But I think this is another reason why law should not excessively intervene in toxicity or other kinds of social problems in hyperscale LLM. Because if law imposes sanctions or otherwise intervene too excessively, then data availability may be impaired, and maybe we will lose our opportunity to update and make a data set most updated. And many biases actually come from historical data that does not reflect recent social changes. And if we, for example, if we filter, if law requires developers to filter, language models too excessively, then maybe we will lose chance to update our language model to reflect such recent social changes or some jargons or even some domain knowledge.
Okay, so thank you for that. Maybe to deep, I wanted to ask again about like the language model that recognizes and self-corrects. So if we have these, if we see other people behave, we kind of learn from their behaviors. And if we increase these usages of language models, and if we see how they can self-correct, do you think that could also give positive impact to how people interact and how they respond?
That's actually a super interesting question. So one point I'd like to clarify, this model I was talking about wasn't just a standard pre-trained language model. We had trained it to be helpful, honest, and harmless from the get-go. And the way we did that was by asking humans to sort of interact with that original pre-trained language model as a chatbot. And then the chatbot would emit sort of, at each turn in the dialogue, it would give you two options. So just two samples from the model. And the people interacting with the model had to pick the most helpful, the least harmless, and the most honest responses. And under the hood, what that allowed us to do was build a data set of AI utterances with these labels, which we could then use to learn a ranking model. So this ranking model takes as input sort of an AI utterance and outputs a score, and that score is higher for something that's helpful, harmless, and honest. Now that is sort of a reward signal, and we use that as a reward function sort of in the in a reinforcement learning setup, where we take our pre-trained language model and say, okay, you have two jobs. Your first job is to be a very good language model. Your second job is to maximize your reward. And so in that process, we've seen a couple of things. Like one, these people tend to find either these models to be sort of great to interact with or extremely annoying. So like a very harmless model can kind of hack its reward by saying, I don't want to talk to you about that. I don't want to do that. So it can basically demure, and then it's sort of no longer engaging. And so the trick is to figure out what that happy medium is. And I think so far I've said some positive things. I can take here's a kind of negative outcome. I can take that same paradigm and flip the sign on harmlessness. And I've actually accidentally did this. And that model was incredibly engaging and incredibly harmful to talk with. And I'll never release that or say anything else about it. So it can go both ways. So you can finally optimize these things for maybe the actual things you want.
Okay, so maybe just adding a little bit of fun to that might be just, would be perfect. Yeah.
Let me share. We have developed a demonstration of chatbot using Hyperscale AI, and we demonstrate to our highest ranked executive, and he replied that, "Oh, that's scary."
Scary.
Yeah, we felt it is a very, very futuristic agent. So we expect he will be astonished by our demonstration, but the answer is something different. So after that, we had studied and concluded that some kind of relationship between human and AI agency will be key to deal with this problem, because we are not expecting someone totally stranger to be friendly or engaging, but we are expecting someone lovers or friends to be very maybe sometimes harmful and engaging. This is kind of a key to balance, maybe the medium point. Maybe it can be a key to solve this problem. Yeah, we should deal with some kind of relationship.
Okay, so I'll go to Haksoo and Hee-jung and try to wrap up. So maybe to Haksoo, what would be the best way that our technology-oriented people can collaborate with like legal scholars like you?
Yeah, I mean, from my perspective, oftentimes you're kind of having a ping pong game between, say, legal scholars on one hand, on the other hand, technologists or engineers. Oftentimes I get questions, for example, give me a metric from an engineer, say equal opportunity or whatever. Then from that metric, we can build a model, we can monitor, or we can assess. Then from lawyers or ethicists, we want fair machine learning, or we want non-discriminatory, or we want something not spitting out toxic comments. And then what's the meaning of fairness, or what's the meaning of toxic comments? And that's the answer that I get from engineers. So there's constant pushback or constant ping pong, and there's no good answer coming out. But somehow we need to engage in dialogue and come up with some sort of solution. So in that respect, oftentimes this attitude I see is sort of we mentioned a checklist. With checklist, it's a good starting point, but I think checklist, if we prepare a checklist, it should be your starting point for dialogue and discussion, rather than sometimes people sometimes think with checklist they have compliance mind. If we can check this, then we are all set. We are free to go. But oftentimes it's not the case. Checklist is just giving some sort of guide as to what kind of items we need to discuss.
Okay, so thank you for that, and we really appreciate like a non-computer science attendees in this conference as well. So maybe Hee-jung, you're from KT, so all the products that should be reaching also children and parents, so it should be pretty safe. And what is the standard, or what are the internal talks at KT related to language models?
Yeah, but, we all have some applications on language models like dialogue system or in Korean Kikaji and smart speaker. And we are trying to remove all the toxic response or biased response. I think we are in the early stage of that development. First, we want to remove all the toxic documents from training data, like some politically biased community or racially biased community. And second, we remove all the documents containing more than unacceptable percentage of controversial words that express bias. Also removed from the training data. Of course, this process is automated. We develop some classifier to filter out the toxic content or data, but it is not perfect 100% of first. So we are trying to give more good classifier. In my experience, more than 20 or more 20 and 50% of the training data were removed with the classifier. But we are collecting a lot of documents to train a lot of language models. So this is not that problem. We are more concerned about the topic contents or bias to the output are given to the child and parents.
Right. So KT is like an internet service provider, but the set-top box, like the TV, works just by listening to what people say. So you can say, Genie, turn on the TV, change the channel. So it's always listening. So there's lots of chat, data that if anyone wants, and you don't want to do internship. Okay, so I think that was fantastic, and I want to wrap up this session with a quote by Emily Bender, who's a UW faculty in linguistics. And on her Medium post, she writes, talking about teaching machine values is fundamentally misframing the situation. It's AI hype. Software systems are artifacts, not sentient entities, and such teaching is misplaced or misleading metaphor. There's something to think about. And I think with that, I would really like to thank all of the audience here for not, being able to have lunch properly, but staying in the session, and thank all the panelists. So let's give big rounds of hands. For the closing remark, we'll have Kyunghyun back.
Actually, can I say just one thing? Just putting on my organizer hat. If you did get your lunchbox, you have to return the box back to the vendor. If that wasn't clearly announced, you should do that after the session.
Okay, thank you again for coming here. Actually, it was a very exciting and fantastic opportunity for me to get some great insight from our speakers and panels. So actually, I organized and had a plan and prepare this craft because we have some worries on how to make the large scale language model based system and deployment, and we want to make people and users happier. But as you know, large language model or hyperscale language model has some challenging issues. So I think Nako and Hwaran and me get some very good hints from our expert, and I hope all of this audience and panels can get some hints to make a better large language model or better AI. Thank you again, all audience and panels and speakers. And the other thing to which that I talk is, please grab our goods in the back side. And if you want, you can get some more sandwiches and cups. Yeah, thank you again.